Hello everyone. Today Robotics will be focusing on trajectory generation. Now what is trajectory generation? It's basically defining the trajectory of a robot with respect to a variable. That is, here we are taking the joint space scheme. That is, we'll be defining the trajectory with respect to the joint angles. Something very similar to the inverse kinematics. Let's look into it. So, a trajectory can be directly linking or moving like this or moving like this. But the thetas will be changing. What we know here is the value of theta at the starting position and the ending position. That is theta naught and theta at TF. That is the final time. So, we say it as theta naught and theta F. Okay. From this, we can say that the velocity at the starting and at the end will be 0 since it's starting from a rest position and it's going to a rest position. So, velocity at theta naught will be 0 and velocity as theta tf dot will be equal to 0. Okay, here we have defined it as a joint space scheme. In the joint space scheme, we are defining the trajectory with respect to a cubic polynomial. So, what is a cubic polynomial? This is the cubic polynomial which we have, that is a0 plus a1t plus a2t square plus a3t cube. a1, a2, a3, a0 are the constants which we are going to find with respect to different trajectories. Let us quickly derive the values. We know that theta dot at any value t will be simply the derivation of theta t. We go ahead and derive it, that is the velocity. If we further derive it, that is, if we further differentiate it, we get the value of theta double dot t as something like this. That is 2a2 plus 6a3t. So we see from the first equation, that is of theta naught of 0 equals to theta naught. We simply substitute the value of t, that is t equals to 0, and we come up to something like this. From the final position, that is the value of theta f at tf will be simply substituting the value of t as tf, and we come up to something like this. Also from the equations of the velocities, that is theta naught dot equals to 0, we put it to the value of theta t dot and we come up to something like a1 will be always 0. When we put the value of tf, we come up to this equation. Okay, now let's derive further. So to obtain the equations of ai, that is a0, a1, a2, a3, we know the value of a0 is equal to theta naught since we derived it from the first and the third equation. Similarly, we also know the value of a1 equals to 0 since we know the velocity at the final position and the initial position is 0, and I just explained you like 2 minutes back. Here we have to find the value of a2 and a3. You can find out that by solving the equations we have initially derived, that is from equations 4 and 6. Similarly, we find out the value of a3 from the 4th and the 6th equations. Now let's quickly hop to a question. You can pause the video and read the question. A single link robot with a robot joint is motionless at theta equals to 15 degrees, which means our starting value of theta is 15 degrees. It is desired to move the joint in a smooth manner to theta equals to 75 degree in 3 seconds. That is, the time period is 3 and the theta final, that is tf of theta, is 75 degree. Find the coefficient of a cubic that accomplishes the motion and brings the manipulator to rest at goal. So what all values do we need to find? That is, we need to find the value of a0, a1, a2 and a3. Now let's look at how we are going to do it. You know that the value of a0 is equal to theta naught. So we simply derive it as 15 degrees. We know that the value of a1 is always going to be 0 because that is what our derivation told us, and we get it as 0. To find out the values of A2 and A3, we find out the value of TF, theta F and theta naught. We know that the theta F is 75, theta naught is 0, TF is 3 seconds. So we put up the values and we get both the answers. So to substitute in the equation, we find out this equation, that is theta T, that is simply putting up the values of A0, A1, A2 and A3. Differentiating it, we come up to something like this, and further differentiating it, we come up to something like this. I hope you guys understood the concept. If you have any queries, please comment below. Thank you. Robometrics.